So welcome to everybody. Unfortunately, I don't see the list of attendees anymore, and I'm not aware about your background. Perhaps the talk is going to be a repetition for you. Let's see. So the title is the ASIL-Palette for functional safety and SOTIF, safety of the intended functionality, the true value of controllability and the need for dynamic reconfiguration. So my intention in this talk is not to offer any solutions, but actually to raise interests around the controllability and possibly true controllability and need for dynamic reconfiguration. So to do that, I will recall background information on functional safety and safety of the intended functionality. And I will also recall information regarding the ASIL and why I'm calling it the ASIL-Palette here, where ASIL stands for Automotive Safety Integrity Level and is also characterized by controllability. So let's start. I typically stress since the beginning the Vision Zero that was, let's say, introduced by Sweden in 1997 and is spread around in the world, and there is recognition of the relevance, where there is a quite important goal, which is reducing or eliminating the number of fatalities in traffic. And of course, this objective is rather utopic. And in the context of the automotive sector, this objective has been targeted by adopting a divide and conquer approach. So safety is, as you can see here by this picture, is a composition of tiles where each tile is actually focusing on an aspect of safety. And in the automotive sector, the first tile, let's say, that was introduced was functional safety, which was defined as absence of unreasonable risk due to hazards caused by malfunctioning behavior of the electric and electronic systems. Now, this was in 2011. After that, the standard has been used, and it has also been a new version has been released in 2018, and a third version is ongoing in order to include the lessons learned. More recently, SOTIF was introduced, and SOTIF aims at targeting another aspect of safety that is defined as absence of unreasonable risk due to hazards resulting from functional insufficiency of the intended functionality or from reasonably foreseeable misuse by persons. Now, to try to exemplify this a little bit more, remaining at the abstract level still, let's consider this other picture where we know that typically we have a behavior that we want to capture, and when we capture the behavior, we do have a specification which represents the intended behavior for a functionality, the nominal behavior, and to give you a more understanding of the functional safety focuses on the malfunctions, so the deviations with respect to those specifications. So failures have to be present. The SOTIF instead is focusing on the fact that you might have underspecified the functionality. So you might have missed something while you were capturing the behavior. For example, this is related to foreseeable misuse by the driver, and perhaps you have not, let's say, designed a proper HMI, human-machine interface. Since the problem of safety in the context of automotive is solved as a risk-related problem, so we are interested in avoiding unreasonable risk with different facets, you can see here that we do have a prescription with respect to the fact that we should adopt a risk-driven process, and risk analysis and assessment is done immediately after the definition of the item. And let's try to understand a little bit more this phase that is done very early in the V model that is suggested to be adopted while you are conceiving your system. So risk is defined as a combination of the probability of occurrence of harm and the severity of harm, where the probability of occurrence is a function of exposure and controllability. So in the automotive sector, risk becomes a function of severity, exposure, and controllability. And briefly, I recall that severity is the potential severity of the resulting harm. The probability of exposure consider how frequent and for how long the vehicle is in an operational situation that can be hazardous if coincident with the failure mode under analysis, and controllability is the ability to avoid harm by the driver. So for those of you who are attending and perhaps are not familiar with all these, let's look at this picture. And let's go backward. So imagine that harm is taking place. There is an accident and people are injured or even killed. And we go backward and we see that we had an hazardous event that is the result of an hazard combined with an operational situation at vehicle level. And then we can trace back in order to understand what had happened at item level, and tracing back inside the item what had happened at the component level. So we see the contribution of the different components. But in any case, when we do the risk analysis and assessment, what we do is that we consider the hazardous event, and we classify it with respect to the attributes that we have seen: severity, exposure, and controllability. Now, if we focus our attention on controllability, that consider if the driver is capable of regaining control, for example, we see that in the palette, in this ASIL-Palette, where we can provide different values for the attributes, regarding controllability, we have 4 values at disposal: C0, C1, C2, and C3, where C0 is controllable in general, so the driver is capable of regaining control. C1, 99% or more of all drivers or other traffic participants are usually able to avoid harm. So this is the idea that you can associate a value to controllability. You can, of course, associate a value also to severity and exposure, and you have similar tables with guidelines in order to establish such a value. But let me continue with the background with respect to ISO 26262 functional safety and ASIL determination. So to perform the ASIL determination, once that you have chosen those values for those attributes, you have a magic table that tells you which is the ASIL. Now, what I want to stress here is that if you choose C0, you do not even have to determine the ASIL. You just exit from the scope of ISO 26262. If you choose C1, you see here in this column that you have a lot of QM, which is quality management. And also in this case, you exit from the scope of ISO 26262, and you will consider other requirements related to quality management. So it is really important, and this is also important, very and exposure, but quite delicate. So it is really important which is the value that you assign to those attributes. And in fact, when the standard initially was introduced in 2011, there were papers that were reporting about how difficult it was and how different results in terms of ASIL values at the end were emerging by different teams if this was done as an exercise. And I see this also in my classes with my students, that they have different brainstorming. So given this table, you might be tempted to go for C0 or C1. Why? Because if you manage to do that, you will skip the work that is expected for different, for the other ASIL values. So if you have A, B, C, D, you have an increased in terms of stringency that you have to take while following the standards. So a lot more of work and a lot more to include in terms of safety mechanism. So if you are tempted, I remind you that there are legal aspects associated to ISO 26262, and not only to ISO 26262, but it has to be stressed here that typically legislation only stipulates that the product shall be safe, and then it relies on standards where the technical expectations are stated via a consensus-based process. And I also wish to remind the existence of the European Product Liability Directive that defines a defective product. So where a defective product also shall include how the product is presented, for example. So it is important also to interpret this figure here, where we highlight that standards as well as regulations result from the, let's say, interplay and efforts, joint efforts, but also conflicts and conflicts of interests among the different stakeholders. So here we may have politicians, manufacturers, suppliers, users. And I'm wondering on which side you are. Me, I'm on the side of those, of course, who are interested in raising the attention on controllability and perhaps carefully assign the controllability value. If we now move to the safety of the intended functionality, this standard also prescribes a process which is aligned with the ISO 26226 process. So in gray, you see the ISO 26226 process, and then you see the activities of the SOTIF process. And at the HARA level, so Hazard Analysis and Risk Assessment level, for SOTIF, you have to elaborate on the risk that might be related by, for example, misuse of the users, the drivers. And with respect to the ASIL-Palette, in the context of SOTIF, there is no need to determine the ASIL. However, the parameters, severity, controllability, and exposure that we have seen before are actually used, and a value is assigned in order to decide what to do with that risk that is elicited, that it is identified. And if it is considered controllable in general, also in this case, you exit from the scope of SOTIF. So now I have decided on purpose, in a provocative manner, let's say, to take as a system the lane departure warning system. So the situation before the introduction of the lane departure warning that there was a significant percentage, 10%, of collisions that were related to lane departure, this at least in the US. And collision means that if you do not keep the lane, let's say, you may have a collision with the vehicle coming in front on the other carriage way, or you may go outside the road, etc. But I want to highlight here that the fact that there are these lane departure related collisions are due to various reasons, and the reasons that in the literature are highlighted are driver fatigue, inattention, drag. So, to, let's say, put a patch on this via an item mounted in the vehicle, a lane departure warning system is expected to warn the driver via, according to the standard 17361, via haptic, audible, visual, or you can choose, or a combination of those. So it means that as soon as you depart from the expected lane, you get an alarm. Now, it's important to highlight that there is no standardized terminology, and manufacturers call the lane departure warning system differently and may offer functionality in combination with, for example, lane keeping. So let's brainstorm with this true value of controllability. And let's consider, for example, the fact that we focus on the presence or absence of the warning, meaning that the warning is not provided and you have an omission, despite the fact that you are in the highway. You are driving in the highway where the functionality is expected to function, and there are road markings that are visible, etc. And you are in a situation as a driver that you are drowsy. But the assumptions are hands-on and eyes on road, and also the fact that the driver should not rely on lane departure warning devices. The driver should demonstrate all necessary behaviors for maintaining correct lane position. So one may wonder, what is the purpose of this functionality if it does not consider the causes of those collisions that are related to lane departure warning, lane departure. And if we consider another scenario that this time is perhaps related to SOTIF, no? Where we have the misuse and we have a visual signal that is not perceivable, and the driver does not pay attention, and perhaps the driver has not received the proper training. So also in this case, which is the controllability? Shall we take the controllability as C0, as this is done apparently by various manufacturers? So what I want to highlight here is that we are in front of a socio-technical system, and we should carefully compose these components where we have the human, the driver, the technical component, which is the lane departure warning system deployed within the vehicle, which in turn is deployed within an ecosystem, a much more complex system. And we do have the organizational component, which represents how the organization within, for example, the manufacturer is organized, but also organizational at a higher level. If you think of Rasmussen's, you may have different layers, and we have seen that we have the standardization layer, we have the layer, so the body that is in charge of the policy making. So in the context of the software center, I had proposed to work on a project called CAST for QA, Criticality Aware Socio-Technical System Architecture for Quality Assurance, with the purpose of reasoning about the different attributes, the flavors of this criticality. And here I'm presenting the initial brainstorming that was conducted in the first sprint with respect to controllability, and I was working also on other aspects. So looking into the details with respect to the lane departure warning system, we see that from an organizational perspective, we have to consider also the fact that the driving license type of test may differ, because it depends when you have taken the driving license. So the assumptions, which are the assumptions on the driver? Because when I took, for example, the driving license, it was not stated anything about the systems that we may have nowadays mounted in the vehicles. Standards may shall be taken into consideration, and standards and regulation may also be in conflict and may state different things. So it is important that when we consider the organization, we decompose the organization and we see the interfaces within the different organization components, we see also the expectations, the assumed and guarantees. Because, for example, the regulation, UNISI regulation 130 is stating something different with respect to the standard that we have seen for the lane departure warning system. Here it is clearly stated that you have to have at least 2 warnings. So you can choose, for example, optical and acoustic. If we take the technical component, of course, we may have, as we have seen, different lane departure warning system, depending on what? Depending on the manufacturer, depending on the levels, automation level. So it is important also that the user manual is really clear. And it is also important to understand which is the environment and where that functionality is mounted. Is it mounted on trucks, on cars? There is a big difference, not only because the vehicles are different, but also because the users are different. Typically, for a truck, the driving license is different. The training is different with respect to cars. So, and with respect to the driver, it is important to be able to elicit the characteristics with respect to the assumptions that we have for attention, decision, perception, knowledge. And if we think about knowledge, for example, knowledge on fatigue, knowledge really understanding the fatigue, because if I feel fatigue, I should avoid driving, for example. And the limitation on the item itself and the assumption on the driver. It would be good to know which are the assumptions that are hiddenly taken. And this also is important to highlight that the functionality can be deployed within different level of automation. And of course, in that case, also the controllability matters quite a lot, because we are, let's say, transferring the controllability to the functionality itself. And perhaps the expectations in terms of reactivity, etc., on the driver shall be clearly stated, and at what time. I know that there is work on a code of practice for the design and the evaluation of ADAS, and this is work also related to understanding how to assign the controllability. And there is ongoing work for automation level 3, for example, and reconsidering the controllability, and work for future. There is an intended, just conceived project for a future standard, considering the artificial intelligence and the controllability, so reaction to uncertainty during transfer the automated functionality to the driver. So from what I have presented myself, I consider that there is an emerging need for dynamic reconfiguration. I do not have solutions here. My aim was to raise interest, understand the position, and eventually work together in order to propose a project in the context of the software center. I thank you for your attention, and it is time to discuss and perhaps know your position. I don't know if there is any possibility in the context of Teams to see votes from your side and understand if you think that checking the real controllability and the assumptions on the controllability at runtime is a necessity